Hi, I'm David from Electric Teaching, and welcome back. This is part 2 of finding derivatives to do the first derivative test on functions. So just a quick review here. We've actually analyzed a cubic function. We found the derivative, looked at the critical points, and made a little chart or made a little table to analyze whether it was increasing and decreasing. And then we took a look at an e to the x graph, with a little twist basically, and we found that it was decreasing and increasing up into the minimum, decreasing into the minimum at x equal 1, and then increasing out of it. Let's see, I'd like to do another one here. The last one I want to do here is a kind of a difficult one. It is a rational function. So this way I've given you kind of a taste of all the most important ones that you'll probably see on a given test. Y equals 1 minus, actually I'd like to do, let me scoot down here a little bit further, and I'd like to do a, use the function, go back to a function notation. I think that's correct. So let's do this. F of x is equal the rational, big fancy word for fraction of polynomials. Rational function y minus x squared over x plus 3. So we got some sort of parabola over a line. I always like to analyze the rational that way. I want to start off again the way I always do. Is there any x-intercepts, any domain issues, any basic pre-calculus analysis we could do with this one? I hope you can see that the top is difference of squares. That makes conjugate pairs. That would actually look like 1 minus x and 1 plus x. Again, it's always good to practice your pre-calc and make sure you understand where we're going with this whole first derivative test. So we can see now that nothing really cancels with the denominator. So there's not a hole in this situation. There's going to be no holes. We're definitely going to get an asymptote, and we've got 2x-intercepts. So what makes 0? My favorite question to ask my students. Okay, what makes 0? We've got x-intercepts at, let's see, x equal plus or minus 1. I forgot to get the equal sign in there. Plus or minus 1. We also have what makes 0 down here. Well, that means we have an asymptote at x equal negative 3. We have an asymptote at x equal negative 3. So no matter what's going on with this graph, well, that was a terrible one. Let me try doing that one again. Sorry about that. Whatever's going on with this graph, we've got x-intercepts at negative 1 and 1, and we've got at negative 3 somewhere over here an asymptote where we're going to see the graph either explode down, explode up. So that's the basics of it. Let's start the calculus portion of it. Let's start the calculus portion of it. Excuse me. I'm having trouble speaking. It's a little bit late at night right now. So let's see. I'm going to do the first derivative. If I'm going to do, I can't simplify this. I'd always look to simplify. People forget sometimes. I want to do a low d high or minus high d low over low squared. I know that sounds funny, but that's low d of the high. This is denominator times derivative of numerator. Low d high minus high d low, high d low over low squared. Just a different way to just say that we're going to take the derivative of the denominator. This is often g prime in textbooks, so g and f, and that would be g prime times f prime minus f prime times g over g squared. So it's the same idea, just another way of doing that. I think I'm going to erase this. I think you got the idea, and let's start doing it. Forgive the extra teaching. I just want to be clear at what I'm doing. Low, especially when I start saying things like low d high, derivative of high, negative 2x. That's sloppy there. Please forgive me. The pen sometimes is not cooperating when I'm coming off one symbol to the next. So we got negative 2x is the derivative. Now we're going to go minus high, 1 minus, again, coming off there. Sorry about that. Okay, 1 minus, okay, got to work a little slower here, and maybe that'll help. 1 minus x squared times the derivative of the bottom. I'll be explicit, the derivative's 1, but really we don't need to do it. Then times the denominator, or low squared. Low d high minus high, numerator, d low, derivative of bottom, denominator. Little interesting way of doing it. I had a calc teacher teach me that years ago, and then I forgot about it, and then a student reminded me of that one somehow. Clean this up. Negative 2x squared. I'm distributing here. Negative 2x squared minus 3x, 2x squared. Sorry about the sloppiness. Pen trouble there. Negative 2x squared, then minus 6x. I think I said that correctly. And then a negative distributed. Watch out. That's a negative 1 and a positive x squared. A positive x squared. So in this situation, when I start to ask what makes 0 of the numerator, I hope everybody recognizes we're going to have a quadratic situation here. We're going to have a quadratic situation here. Derivative of x. Man, the pen is really connecting on these points. I think it's the way I write. I apologize. All right, final little point here is I'm going to collect like terms. We're going to get a negative x squared minus 6x minus 1 over, again, x plus 3 quantity squared. Technically, I would like to factor out another negative. I know I might be taking a little bit of extra time here, but I think it's important to recognize that if I was to try to factor this, they rarely are factorable when you get into this point of calculus, but if I was to try to factor this to answer the question, what makes 0, it's always better to have a positive x squared. So now we have x plus 3 still downstairs, quantity squared. Never ever expand that because we want to ask what makes 0. Do we have a critical point? We do have a critical point at negative 3. That's the first critical point I see. That's the domain error. Why do we have a critical point? Why can't we take a derivative there? Why can't I plug and chug a negative 3? Well, at x equal negative 3, that's an asymptote. And so what we're thinking there is we can't take a derivative. The graph is either exploding to one of the other infinities. It's continually increasing or decreasing to one of the infinities, and we can't take a derivative at x equal negative 3. So that just kind of confirms that the asymptote's there. So that'll stay the consistent. Numerator, a little bit different. Numerator's just a bit different there. If I was to ask what makes 0 here, this is going to require the quadratic formula, or maybe even completing the square real quick could be a quick trick. So many of you are comfortable using the quadratic formula. Just for kicks, I'm going to show you how to complete the square pretty quickly. I'm not going to go through the lesson of it. I'm just going to give the steps to it, and hopefully you remember some of these steps. So with that one, what we want to do is we want to take x squared plus 6x. We're trying to figure out what makes 0, and I'm going to set the plus 1 aside. I'm going to set kind of the plus 1 aside. I just think about it set aside over here. It may have been out of the video there. I apologize. Well, plus 1 is just off there. I'm going to take the binomial, half of b. It's not that hard to take half of that even number. So half of b, half of positive 6. That's a positive sign. Sorry about that. That's a positive sign there. Please forgive the pen's not working very well here. So if I want to get it, that's half of b. Well, I just added a 9. Can you see the 3 squared here? I just added a 9. So technically, I have to subtract the 9. I have to subtract the 9, and I have to add 1. So the actual vertex form, I just put this in vertex form if you don't recognize, looks like this. X plus 3 quantity squared minus, I don't know why that says 8. I was probably thinking ahead. This is supposed to be plus 1. So it's minus 9 plus 1, which is minus 8. Sorry about that. I think my brain was thinking ahead there. All right, now to set this equal to 0 still looks intimidating, but it's really not that hard. If I set this equal to 0, I'm going to add 8, square root, subtract 3. I'm going to repeat that. I'm going to add 8, square root, subtract 3. So this one really isn't that hard. Add 8, add 8 to both sides, square root, that's plus or minus square root of 8, Okay, now this is equal to x plus 3, so I did the first two steps. I'm going to rewrite it now, rewrite it just a little bit, switch sides. I'm now going to have x equal, let me rewrite that again, sorry, x equal negative 3 plus or minus root 8, plus or minus root 8, negative 3 plus or minus root 8. Root 8. Square root of 8 is just about 3. So roughly, we have critical points again at negative 3, which happens to be our asymptote here, plus 3. So that'll take me almost to 0. Almost to 0. Square root of 9 is 3, so this has got to be just shy of it. So it's going to take me probably right around there, so close to 0. And negative 3 minus about 3. And so the other critical point is down here, very close to negative 6. Very close to negative 6. Somewhere right around there. So now let's do our analysis. I hope you liked how I used completing the square. It came out looking exactly like the quadratic formula would do, but just a little bit of a different way if you don't like plugging and chugging the old formula. Now the analysis. Now the analysis. Sorry if this is taking a little bit too long. We'll go through the analysis hopefully quickly here. So I'm going to plug and chug. Again, I'm going to try to plug and chug in something simple. This seems to be the simplest place to plug and chug. Again, I'm looking for positive or negative values. I got a negative on the outside. If I put in, I don't know, maybe negative 10 or negative 100, I'm thinking of a big number. This will be a positive value that'll be so big that it'll dominate it. Does that make sense? This will be negative 100 squared, so that'll be a 1 with 4 zeros. So that's going to be pretty big, so that's what, obviously going to make this whole thing positive. So that'll be negative times a positive, and then if I put a negative 100 downstairs, hey, everything's squared downstairs. Everything will be positive. So I have a positive and a negative and a positive all multiplied. So this thing is decreasing. I'm going to put a big symbol here to tell me that it's decreasing on this side. If I put in any value in here, let's say I put in a value of negative 5. Negative 5 now. I'm going to see a negative on the outside, a positive on the denominator, because that's always the case on this. So I just need to figure out what's going on here. So if I put in a negative 5, that's going to be 25 minus 30 plus 1. I think you can see that that's going to be a negative answer. So again, we're going to have a negative value on the outside times a negative divided by a positive. Can you see the results of this? The results of this will definitely be a positive answer. 2 negatives and a positive. This answer will be positive. So now I know that I'm going to be, I'm trying to figure out where to put a plus sign, positive or increasing at this moment. Got another critical point over here. Got another critical point right before 0. So I'm going to plug and chug another value over here, like negative 1. Again, the outside's negative right here. The bottom's always positive because we're squaring. It'll always be positive then, right? Kind of like absolute value. So it just matters what negative 1 will produce. Negative 1 will produce a positive, a negative, and a positive. So let's see, that'll be positive 1 minus 6. Minus 6. So this is going to be a negative value. I think we're going to see a negative times a negative times a negative, and divided by a positive. So again, it seems that I'm going to be increasing after the asymptote. I'm going to be increasing after the asymptote. So that's interesting. I have 2 positives back to back. Lastly, and this is why this took a part 2 of a video, it takes a while to go through these, I'm going to plug and chug something real simple, guarantee what the condition will be. So let's plug and chug way out here, because I can go all the way out to positive infinity. So let's plug and chug 100. We're going to get a negative, clearly a positive as I explained earlier, so times a positive divided by a positive. A negative divided by, or times a positive divided by a positive. So let's see, that would be then negative. So whatever this graph now looks like, sorry, I scrolled down there pretty quickly. whatever this function looks like, I know these things, okay? I'm going to try to actually select and bring this part of the graph out a little bit more. Let me see if I can select all of that real quick and grab and bring this part down. And grab those intercepts and those asymptotes and bring them down. Cool. All right. Now, whatever we know about this graph, and later you're going to learn more and more in calculus about what the graph's actually doing. But what we know for sure is that it seems to be decreasing completely on this side of the asymptote until we get to, oh, excuse me, I forgot about the -6 point. Let me back up. Got to extend out the positive line. So somewhere over here at about -6, again, about -6, just shy of it, seems to be decreasing into somewhere over here. Could go, I don't think it's going to go below the axis because I don't have any intercepts. So it's probably going to stay above the axis. Again, I can't be really decreasing and then increasing into an asymptote, into this asymptote, because that's what it says it's going to do between -6 and -3. It's going to be increasing now between -6 and -3. So I'm assuming this graph does some sort of churn above the x-axis, because otherwise we would have intercepts, meaning we would have had what makes 0 again at the top. Over here on the other side, apparently it is increasing again. So apparently I am increasing. I need to change colors of my graph. Let's make the graph with black. So this is apparently about what the graph's doing. I don't know much beyond that. Excuse me. I am also seeing a positive and increasing between -3 and 0. So this graph seems to be increasing, probably coming off the asymptote. Looks like we might even hit these intercepts because we churn and go decreasing somewhere after 0. So somewhere after 0, probably turning above the x-axis. So it probably does something like this. And then heading off, I don't know. It says it's decreasing. Don't know. Could, if it leveled off, it would still be decreasing. So it could level off, but it just kind of depends on what else is happening. Well, I've spent over 15 minutes on this video, and that's kind of over the length I prefer to go. I've actually graphed this equation. I graphed this equation, and I just want to show you what it looks like. And it does pretty much what we said it was going to do. We just didn't know exactly where the minimum was going to happen, but we knew there was a minimum somewhere because it went from decreasing into about -6, and then it started increasing, and it had this asymptote, so we'd have to assume it exploded up, and it did. As I said, it was coming from -infinity off the asymptote because we knew it was increasing as we move left to right. This is getting higher and higher and higher. It's increasing. We knew it hit the intercepts, and as I predicted, somewhere up there it crossed. I guess I could have found the y-intercept, might be close to that. And then it started decreasing. It looks like it kind of decreases on a linear path. So you learn more about how to graph this probably later in calculus classes. Man, I'm David from Electric Teaching, and I definitely have taken way too long on these videos, but I really wanted to be sure you understand how we can really analyze a lot about these graphs and a lot about functions in general using the first derivative test. I hope that I have helped.